20 massive tech inventions that will change humans' future forever. Artificial intelligence AI systems that can continuously learn, reason, and make decisions will transform how humans live and work. AI agents could take over dangerous jobs, provide personalized recommendations, automate business processes, and assist in nearly every industry. Sophisticated AI could even match some levels of human intelligence. Robotics. Advanced robots will integrate artificial intelligence to take on increasingly complex functions. Robots with fine motor skills and mobility could assist the elderly, work as companions, serve customers in retail settings, deliver packages, perform surgeries, construct buildings, and even help colonize other planets. Continued improvements in robotic capabilities will expand how they can help humanity. Self-driving vehicles. Autonomous vehicles equipped with sensors and powerful onboard computers will navigate roads safely without human input. This disrupts existing transportation models. Besides reducing traffic accidents, self-driving cars provide independent mobility to the disabled and elderly. New vehicle ownership and ride-sharing models may arise. Urban planning also evolves with potential reductions in parking infrastructure needs. Commercial space travel. The development of reusable rockets has dramatically lowered launch costs, enabling cost-effective space tourism. Orbital hotels, commercial research stations, and even off-world colonies could be constructed. This expands economic opportunities in space along with options for exploration. Advancements in propulsion, like scramjets and nuclear fusion, may allow rapid intercontinental flights and trips to Mars. Hyperloop transportation. The Hyperloop concept uses magnetic levitation in a low-pressure sealed tube to eliminate air resistance. This allows capsules to travel at over 1,000 km per hour for rapid transit between cities over 1,000 km apart. Travelers could commute long distances in a fraction of the time. Hyperloop networks would reduce short-haul flights, road congestion, and emissions. Gene editing tools like CRISPR give scientists the ability to make precise edits to DNA sequences and alter gene function. Genetic diseases could be corrected, protecting future generations. Gene editing may also enhance human capabilities, enable designed babies, revive extinct species or create new synthetic life. This disrupts medicine, agriculture, conservation and ethics. Exoskeletons. Wearable robotic exoskeletons use motors and hydraulics to augment human strength, speed, endurance and mobility. Applications range from helping the disabled walk again to aiding soldiers, first responders, construction workers and senior citizens with strenuous tasks. Performance-boosting exoskeletons may also benefit athletes. Flexible exosuits could even allow humans to comfortably explore extreme environments like the deep sea. Smart cities. Cities embedded with ubiquitous sensors, meters, cameras, robots and other connected technologies allow real-time monitoring and automation of infrastructure and services. This improves efficiency, sustainability, convenience and quality of life. However, smart cities also raise concerns about surveillance if citizens' activities are tracked. Augmented and virtual reality. Immersive extended reality technologies overlay digital information and simulations onto the real world or replace it entirely. AR could replace smartphones while VR replaces TVs, enabling more seamless communication and entertainment. Other applications range from training simulations to remote surgery assistance in medicine. Challenges include preventing disconnection from physical reality. Flying cars. Lightweight electric vertical takeoff vehicles will provide personal air transport without needing runways. While still early stage, prototypes use distributed electric propellers or lift and cruise systems for vertical flight, switching to aircraft-style propulsion. Autopiloted flying cars could revolutionize urban commuting but also raise noise, safety and infrastructure concerns. Lab-grown meat. By culturing animal cells, lab-grown meat could reduce land and water use, pollution, deforestation and animal suffering associated with traditional livestock farming. It also enables innovation of new food textures and nutrition profiles. Costs need to become competitive with conventional meat. Overcoming reluctance to eat artificially cultured food is another challenge. Green energy. Advances in solar, wind, geothermal and tidal energy harnessing combined with progress in energy storage, smart grids and hydrogen fuel cells could provide consistent renewable energy globally, reducing carbon emissions. Nuclear fusion may provide future clean energy through replicating solar power on Earth. Transitioning energy infrastructure presents economic challenges. Precision medicine analyzing your genetics, microbiome, lifestyle and environment data enables personalized healthcare. Doctors can provide individually tailored disease screening and treatment recommendations. Targeted therapies attack abnormalities specific to each patient. However, precision medicine raises privacy concerns about genetic data sharing. Exoplanet travel innovations like nuclear fusion rockets, antimatter drives, laser sails and ramjets could enable probes to approach light speed. This opens the possibility of human spaceflight to neighboring star systems and interstellar colonization. However, energy requirements are immense and journeys would still take decades or centuries. Digital security, unhackable quantum networks, decentralized blockchain ledgers and quantum cryptography could provide future data security. AI cyber defense also evolves to counter threats. Digital privacy may be strengthened through regulations. Drawbacks include cost, complexity and lagging adoption. Brain-computer interfaces implanted electrodes allow users to control computers and machines simply by thinking. This provides direct communication without speech or gestures. BCS could restore communication for the paralyzed and disabled. Seamless human-AI integration and cognitive enhancement are also envisioned but raise ethical issues. Smart materials substances like shape memory alloys and hydrogels respond dynamically to environmental stimuli. Applications include self-healing and self-cleaning surfaces, morphing wings, blades, personalized medicine, responsive architecture and wearable energy storage. Sophisticated materials could enable more resilient and efficient designs. Space-based manufacturing. The microgravity environment of space enables manufacturing processes difficult or hazardous on Earth. Products such as optical fibers, pharmaceuticals, alloys and crystals can be fabricated with higher purity and performance. However, space manufacturing costs are still prohibitive. Renewable energy storage grid-scale batteries and pumped hydro facilities allow surplus renewable energy to be stored for consistent clean power 24/7. Improved batteries also support transition to electric vehicles. However, storage technology must keep pace with renewable energy expansion. Quantum computing. Quantum bits in superposition enable massively parallel computation, allowing problems deemed impossible for classical computers to be solved. This revolutionizes fields like physics simulations, drug development, machine learning, cryptography and more. But quantum computers remain error-prone and limited in scale. Kindly subscribe for more videos. Thanks for watching Falcon TV.